What if I told you the sun is constantly trying to explode, not metaphorically, not someday in the distant future, right now? At this exact moment, the star that gives you light, warmth, and life is balancing on the edge of destruction. And the only reason it hasn't already torn itself apart is something so strange, so deeply hidden in the laws of the universe, that even today, most people never truly understand it. But here's where it gets strange. Because if you look at the sun from a distance, it seems calm, stable, eternal, a perfect golden sphere, rising and setting as if nothing could ever go wrong. But inside, it is chaos. Imagine pressure so intense that atoms are crushed together. Imagine temperatures so high that matter itself forgets what it used to be. At the core of the sun, hydrogen atoms are being forced so violently together that they fuse into helium, releasing enormous amounts of energy, energy that should rip the sun apart. And that raises a bigger question. If the sun is producing this unimaginable energy every second, why doesn't it explode? Why doesn't it become something like a supernova, a catastrophic blast that would erase everything in the solar system? Because according to everything we know, it should at least be unstable, but it isn't. And this is where everything changes. You see, the sun is trapped in a silent war, a war between two forces that should never be able to perfectly balance each other, yet somehow do. On one side, gravity, an invisible force pulling everything inward, crushing, compressing, trying to collapse the sun into itself. On the other side, nuclear fusion, an outward explosion happening continuously, a force pushing outward with incredible intensity. If gravity wins, the sun collapses. If fusion wins, the sun explodes. So why does neither happen? Why does it stay suspended, perfectly balanced? But that is only half the story. Because this balance isn't stable in the way you might think. It's not like a rock sitting peacefully on the ground. It's more like a pencil standing perfectly upright on its tip. Impossible, fragile, one tiny shift, and everything should fall apart. Yet the sun has been doing this for over 4.5 billion years, and scientists found something even more disturbing. The equations that describe this balance are incredibly precise. Too precise. They suggest that even the smallest change in the sun's mass, temperature, or internal pressure could trigger a completely different fate. Collapse, explosion, transformation. But none of that happens. Instead, the sun continues steady, predictable, almost eerily calm. And that raises a bigger question. Is this balance just coincidence? Or is there something deeper controlling it? This is where Roger Penrose enters the story. A physicist who spent his life thinking about the most extreme forces in the universe. Black holes, space-time, the edge of reality itself. And when Penrose looked at stars like our sun, he didn't just see burning gas, he saw something far more unsettling. He saw a system that behaves as if it knows exactly how to avoid destruction. But here's where it gets even more unsettling, because according to Penrose, the sun isn't just balancing forces, it's balancing probabilities, and that changes everything. Because if you think about it, there are infinitely more ways for the sun to be unstable than stable. Infinitely more ways for it to collapse or explode than to remain exactly as it is. So why does it choose this path? Why this narrow, fragile state that allows life to exist? And this is where the mystery deepens, because the answer doesn't just involve physics, it touches something far more uncomfortable. Something about time, entropy, and the hidden order of the universe itself. But before we can understand that, we need to ask a more dangerous question. What if the sun isn't avoiding explosion by chance, but because the universe itself is forcing it not to? And if that's true, what else is being held together that should have already fallen apart? And what happens when that balance finally breaks? Because according to Penrose, it will, but not in the way you expect. And the reason why is where everything you think you know about the sun begins to unravel. Because to understand why the sun doesn't explode, you have to stop thinking of it as just a star. You have to think of it as a moment in time, not just any moment, but a very special one, a moment that, according to Roger Penrose, should be almost impossible. But here's where it gets strange. In physics, there is a rule that governs everything. A rule so simple, yet so absolute, that nothing escapes it. Entropy. The idea that everything in the universe moves from order to disorder. Ice melts, stars burn out, structures collapse. Given enough time, everything falls apart. But the sun doesn't look like something falling apart. It looks organized, structured, stable. It has layers, balance, rhythm. And that raises a bigger question. How can something so violently chaotic on the inside appear so perfectly ordered on the outside? According to Penrose, this is not normal. In fact, it's deeply unnatural, because the early universe itself, the moment after the Big Bang, started in a state of extremely low entropy, a state of incredible order. And that is the real mystery, not why things fall apart, but why they ever started out so perfectly arranged in the first place. And this is where everything changes, because the sun is a direct consequence of that original order. Its stability, its balance, its refusal to explode, all trace back to something that happened billions of years ago, something that set the rules. But here's the unsettling part. Penrose calculated just how unlikely that original state was. Not unlikely in a casual sense, unlikely in a way that almost breaks comprehension. The odds of the universe starting in such a perfectly ordered state are so small that writing them down would require more zeros than atoms in the observable universe. Let that sink in. The sun is stable because the universe began in a way that almost should not have happened. But that is only half the story. Because if the universe is constantly moving toward disorder, then the sun's balance is not permanent. It is temporary. A slow, controlled delay of the inevitable. Every second, the sun burns hydrogen into helium. Every second, it loses a tiny piece of its original simplicity. It is aging quietly, relentlessly, and this is where it gets uncomfortable. Because the same force that prevents the sun from exploding is also the force that guarantees it cannot last forever. Gravity holds it together. Fusion pushes it outward. But over time, the fuel changes. The balance shifts. And one day, the war inside the sun will no longer be equal. But scientists found something even more disturbing. When that moment comes, the sun still won't explode like you might expect. No massive supernova, no sudden destruction. Instead, something slower, stranger, almost more haunting. It will expand, it will grow, swallowing the inner planets, becoming a red giant, a bloated version of itself. And here's the paradox. The sun avoids explosion, not because it is safe, but because it is trapped in a very specific path of evolution, a path determined from the very beginning of time. And that raises a bigger question. If the sun's fate was decided billions of years ago, how much of the universe is already written? How much of what we see is just the unfolding of an ancient, improbable beginning? And this is where Penrose's idea becomes almost philosophical, because he suggests that the universe is not just expanding randomly, it is following a direction, a flow from extreme order to complete chaos. The sun exists because we are still somewhere near the beginning of that journey, a brief window where structure is possible, where stars can shine without exploding, where balance can exist even if it shouldn't. But here's where it gets even more unsettling. Because if entropy always increases, then one day there will be no balance left to maintain. No gradients, no tension between forces, no reason for stars like the sun to exist at all. Only uniformity, only stillness. And this is what Penrose calls the real end. Not fire, not explosion, but silence. A universe so spread out, so evenly distributed, that nothing happens anymore. No stars, no light, no structure, just a cold, quiet infinity. And suddenly, the question changes. It's no longer why doesn't the sun explode? It becomes, why does anything exist in this fragile, balanced state at all? Why now? Why this brief moment where the impossible seems stable? Because if Penrose is right, then the sun is not a permanent object. It's a temporary exception, a flicker of order in a universe designed to erase it. And that means, right now, as you watch this, as the sun rises and sets like it always has, you are living inside one of the rarest conditions the universe will ever allow. A moment where a star can burn without exploding. A moment that should be far less likely than we ever imagined. And the most unsettling part, we don't fully understand why it was ever possible to begin with.